So, welcome everybody. As many of you will know, security is a matter nowadays, so we welcome Thomas, who should tell us how to make security work properly in Python programs, I suppose. Thank you, Thomas.
Okay, thank you. Okay, welcome. This talk is mostly about the server side, as the title says, so I won't talk much about how you should create your passwords. You have to make up your own things somehow. So this is mostly about server software dealing with passwords and how to store them and so on. That stuff has a quite long history since the 60s, 70s or something, and there were lots of failures. And if you read IT news, there are failures every week and lots of passwords get exposed somehow. And this is how to avoid the worst consequences of it. You read the disclaimer, I'm not a security expert and this won't be too deep into crypto or something, it's more about getting awareness of the problem. So, short about me, this is my name, I'm doing Python since quite a long time and I'm mostly working on the Moin Moin wiki project. Mostly in my free time, sometimes also in work time. I'm using Linux mostly, and I love free and open source software and Python and wikis, obviously. I have a small company near Stuttgart, and we're doing all sorts of stuff, administration services, sometimes training, and also sometimes software development. Why I'm doing this talk, we had a rather severe issue at the end of last year. And it was about remote code execution. That's maybe the worst stuff that can happen to your server application. Usually Moin Moin has far less secure issues, so sometimes there was a cross-site scripting thing or something. But remote code execution means the attacker can execute code on your server, and if he can do that, he can basically do everything that is permitted within the permission of that user the process is running as. So the consequence was that some wiki sites got compromised. Maybe you heard from it, Python wiki was completely erased. There was no data left on the server. So it all had to get restored from search engine index backups, kind of. Yeah, and I had to do a lot of incident managing related to that, and our own wikis, of course, had the same sort of issue. They did not get erased, but the bug, of course, was also there before it was known. And it took quite a long time to deal with all that stuff, and so this is kind of the aftermath. The talk is mostly about awareness, so you are all aware that you need to do something if you are not using the latest, best method I will propose later. And you should also be aware that you have kind of a responsibility for your users' passwords. Of course, you can't help about how good the passwords are. The user has to choose it himself or herself. But you have a responsibility to store them rather safely, so they can get copied or cracked easily. And you should maybe assume that at some time shit will happen and someone will break into your server and will steal your hashes or something. So it's good to be prepared and have a plan beforehand, because you just can react faster to the issue then. I'm only talking about this first thing about user IDs and passwords. There are lots of other ways how to deal with authentication. You can use SSL client certificates, LDAP, OpenID, Mozilla Persona, and tons of other stuff. This is only if you deal with passwords in your own application code. The other stuff is somehow outsourcing it from your application to another server. So if you have to deal with passwords yourself, you will need to have some sort of user profile. It's either a record in your database or a file on your disk. And the user profile usually contains a username, email address, all sorts of settings. And you also will have to store something that you will need later to verify the clear text password. And maybe remember these shortcuts, I will use them later. P is that something, and the clear text password is CTP. So this is what a user is typing at the login prompt, and P is what you have in your profile. So the simplest method is, of course, you just take the clear text password and store it into the profile. This was a popular method in the last millennium. And as you can expect, it's maybe not the best idea, because it was used in the early ages of computing, when security was not that big issue, or people thought it is no big issue. And so it was in the 70s mostly, or even earlier, where password just got stored this way. It's a bit different. Some manufacturers maybe even store clear text passwords now, even if they could do better, so it's not quite solved yet. I hope you all don't do that, but you might find some places where it's still done that way. The problem is, if you do it, basically sooner or later your users will be globally owned. Someone will break into your system, or even have legitimate access to your system. For example, an administrator, he can just look into the profiles, and he will all have all the emails, he will have all the passwords, he will all have all the usernames. And as many users reuse their passwords at many sites, even the administrator can do evil stuff to them. And of course, if some evil guy breaks into the system, the same thing can happen. You have also to think about, for example, if you fire an admin, and if he has all your passwords, he can somehow strike back. So, and a special thing is, many sites nowadays use the email as unique identifier for a user, because it's usually globally unique. But if you use user ID equals email and password, and you have both, that's globally the same everywhere. So you have everything you need to log in at many other sites. So okay, so clear text is bad. So you can think of, okay, let's make it non-readable somehow. So there are some methods, rot13, just rotate the characters, or use some XOR-based method, or encode it somehow. You can't see the password if you look at it, but the problem is this is rather about obscurity, not really security, because you can just do the reverse operation and you have the clear text again. So this idea is as bad, about as bad as the clear text storage, so don't do that either. Okay, so the next idea is encryption is great, so let's use encryption. So the method would be, you get the clear text password, you have an encryption key, you apply some encryption method, for example AES or DES or some other symmetric crypto algorithm, and then you store the encrypted password into the profile. And at login time you read it from the profile, decrypt it again, and compare it against the clear text password. Well, there is also a problem. You should not do that. The problem is, of course, it's symmetric, and you need the key on the server to be able to decrypt the password. So if someone attacks your server, he can steal the crypted passwords and the key. And he can decrypt all the stuff, so you are back to clear text again. So it's not that great. You can't read it immediately, but as you have to have the key somewhere, and you have to have it on the server usually, you don't win that much by it. There might be one chance where it is not that bad if your server has some mean to store keys securely. Maybe something like a TPM or something, or a special hardware device that doesn't just give out the key. But if you have to store the key in a configuration file or in an extra file on your disk or in your database, you basically win nothing. So don't encrypt passwords. So, of course, as many of you know, crypto hashes are part of the solution, and the usual way is, if you use a simple one-way crypto hash, you have the clear text password, you apply a hash algorithm to it, and then you store the hash into the profile. Popular hashes, MD5, SHA1, NTLM, APR1, whatever. The good thing about the hashes is they are only computable easily in one direction. If you have the clear text password, you can quickly compute the hash. But if you have the hash, you can't quickly compute the clear text password. So it's a one-way thing, and this is the good thing. These methods are rather popular even right now. I have seen code that just uses this. But there is a problem. So even if you use this nice hash from the standard lib in a simple way, it is still wrong. There are several reasons for this. If you have the same clear text password, if multiple users have the same clear text password and you apply the same hashing algorithm, the output will be also the same. So for example, if some employee has password foo, there will be some specific hash, and if the boss also has password foo, there will be the same hash. And if someone looks at this and he knows the passwords of the one guy, he will also know the password of the other guy. So this is bad. Additionally, some algorithms are weak. For example, you maybe know MD5 is not the greatest strength algorithm. Some older hashes also produce rather short output, for example 64 bits or something. And if you attack it by brute force or something, the shorter the output is, the faster maybe you can crack it. Also, if the output is rather short, you can just compute all possible outputs somehow and make a reverse table. So you can replace the reverse direction by just a table lookup. This is called a rainbow table. So it's basically a table with the hash on the left side, so the key is the hash, and on the right side basically is the password. So this one-way property, you can work around this if you have a rainbow table. And for some popular algorithms used in the past, you can download rainbow tables or buy a hard disk that has the rainbow tables. Often they are rather big, so very many gigabytes or even terabytes of stuff. But if you have some fast means to use them, it's just like a database lookup. So it's not slow. You can break it easily. And this stuff, many people are aware of it, and there is a solution against this rainbow table attack. So this is what's widely known also. You can solve that rainbow table attack or countermeasure it by adding some salt. So what you do is you compute some random string, for example 32 bytes long, and then you add that salt to your clear text password. Usually it's a concatenation here. So both values go into the crypto hash, and you also store the salt as clear text. The salt is not a secret. And this thing avoids, because it's random, this avoids that multiple people having the same password also will get the same hash. They all will be different because the salt is random all the time. And if you verify it, you have to know the salt, put in the salt, put in the clear text password from the password prompt, and you can verify it if it's the same again. The problem with the short bit length, you can also use just longer bit lengths and get a bit more security. So this rainbow table attack is maybe not doable for that stuff if you do it like this. You can also use a so-called pepper. Pepper is basically the same as a salt, but the salt gets stored with the password into the database, into the user profile. A pepper you usually keep somewhere else. So for example, if you have some SQL level exploit and someone can do SQL queries and maybe get the hashes, he maybe still can't get the pepper that is stored into your configuration or somehow. So it's a bit additional security, but it works in a similar way. So, okay, we have more or less defeated that rainbow table attack. But it somehow is still wrong, or rather not adequate for today. And it's because of this. So, this is an AMD graphics card. It's rather fast. It has many cores, quite quick memory. And the problem is it can compute about 1 billion hashes per second. So now just imagine you have a more or less easy password and you can try 1 billion tries per second, just trying to brute force it. And now imagine how long the typical user's password will resist this attack. It could be milliseconds, maybe seconds, maybe hours, maybe days, but not too long usually. So this is a problem, and the salt does not help you against it, because the salt is known. It can be part of the brute force. So the salt is only good against rainbow table, not against brute forcing with high speed. So the usual method you could do, or the simplest method, is you just begin with some start value and then completely iterate to the end value and try all possible passwords. You need to try different lengths, of course, but you can imagine if you have that sort of power, it will go rather quickly if the password is not too long. And additionally, this is not uncommon hardware. Every gamer has this. And you can buy it for whatever, 300 or 500 euros. And if you imagine that even a gamer has 1 or 2 of these cards, imagine what a government could buy, or mafia, or somebody who has endless money. They can buy thousands of these cards and break with 1,000 billion tries per second. If you are interested in the practical software, this is the URL. It works on NVIDIA, AMD, and some other cards supporting the same API. So what you can do is the simple brute force attack, just beginning at a start value, iterating through all possibilities. But that could be rather slow if the password is maybe longer than 8 characters or so. But you can also use dictionaries. So for example, if there has been break-ins in the past and some breaked passwords has been exposed on the internet, you can just put them into your dictionary. You can also use the usual English, German, Spanish, French, whatever words, and just try to combine them in some ways, or use popular rules people usually use to obfuscate the stuff. You can insert, append, and delete characters. You can basically do everything you can imagine someone would use to somehow make his password more complicated, and just put it into an algorithm and basically try to generate input for your brute forcing mechanism. You can also add some numbers if you assume that maybe some people add their birthday somehow, or their child's birthday or whatever. So basically just do the same stuff humans usually try and put it into the algorithm, and then you maybe get the first hits rather quickly. For example, if someone used a dictionary word and your dictionary is 1 million entries, you could have the first hit after a millisecond if you break at 1 billion per second. And after you have found additional passwords, you can feedback them into the dictionary. So you maybe have seen the biggest problem is the rate of tries per second you have now for attacking this kind of systems. So the problem is, or the solution is, we really don't have a need for speed here. These hashes like SHA, they are somehow optimized for speed. So you can compute kind of checksums of large data sets. But in case of passwords, the data set is not large, it's only a few bytes. So you can use more expensive algorithms. And the good thing is, if they are more expensive in a mathematical way, they are also more expensive to break. So you won't have a rate of 1 billion per second, you maybe would have a rate of 1000 per second or 100 per second. And that would be a good thing. So basically one does not just use these simple hashes, but one needs a slower thing that is optimized for password storage need. I will come to that back later. There is some other stuff right now. But this is the basic idea. We just need something slower, that's mathematically slower, not just a bad implementation, of course. Because the attacker, of course, could have a better implementation, so it needs to be slower in theory also. Aside from that speed issue, there are some other troubles. To make this example, we take some assumptions. We assume for this case, because it does not matter that much, that we have clear text passwords stored. We also assume that they never get disclosed or stolen. And then you have in your code, somewhere you have that sort of code. You have the password entered at a login prompt, and you have your stored password, you compare them, and this is a Boolean expression, and you know, okay, if it's true, then the login is successful. So this code looks somehow okay. It's somehow foolproof, right? Who sees a problem in this code? Okay, a few ones. The problem is this, it's timing. So this is the attacker, what the attacker tries, and this is what your real password is that you have stored in your database. And if you do that comparison, Python will compare the first byte and see, okay, it's wrong, and then it is finished. After one cycle, it is finished. Then you try the next one, just increment it, and then it suddenly takes 2t until it finds the next different character. And you see, it always jumps in the timing if you guessed right, because it needs to compare one more. So basically this Python speed optimized string comparison is somehow a traitor. It is telling your password. You only need n or m times n tries to find the password, so you will find it rather quickly. The solution for this problem is you always compare all bytes, even if you could know before that they are not the same, just to make the timing right. So your timing will always be about the same. And you need some sort of constant time comparison function, not this optimized equals operator. Another problem is if you just say, you usually should say your username or password was wrong. You don't say your username was wrong or your password was wrong, because you would tell too much basically. The problem is if your code has different timing to detect those two cases, the attacker can find out by just examining the timing. So the lessons learned basically is better don't use homegrown password code. You can do things badly easily. For example, if you overlook that constant time thing. And it's also work to write all that code and maintain it and so on. So you should use a password library, assuming that it's done right and that many people use it, many people look at it. So it's also a point of collaboration. And yeah, this is what I want to recommend to look to you to look at. There's a library called Parslip. It's on Google Code. And it has a quite nice API. Some frameworks do it a bit differently. For example, Django has its own password handling stuff. It's not using Parslip, but it still uses quite sane algorithms. For example, this one by default. So Django is also quite okay. There are also some other libraries than Parslip. For example, this PyBcrypt library or PyPBKDF2. And maybe there are also some others. These are the ones I found immediately. So back to Parslip. It's BSD license, so many of you can use it. It's pure Python in the biggest parts. Some parts require C code. For example, if you want to use bcrypt, then you have a binary dependency. But if you just don't use bcrypt, it's pure Python. You don't need a compiler to install it. So it's quite nice if you just want to bundle it somehow, or if you want to deploy on Windows and don't have a compiler. And it has strong algorithms. For example, this one or that one. The script is important here. It's not the same as the simple hash. And the thing about those hashes is it's not just doing a single hash application, it's doing multiple rounds, usually 60,000 or 100,000 hash computations. So this stuff is rather slow, so it's hard to brute force it. It also works in Python 3, by the way, so you won't have an upgrade problem with it. Documentation is also quite nice. And here you see it's simple to use. You can just do some import. You get such a password context object, and then you can just say encrypt. It's not really encrypt, it's rather do the hash I want. And you give the password, and this is the call for a normal user. You can also call it that way. And basically by saying category admin, you tell it you can take a bit more time to make this secure. You don't need to be fast like for a user. It can take double the time or three times the time. And this is the call to verify some given clear text password against such a stored hash we got here. And you see there is no equals operator you do in your code. It is done inside a library, and he uses constant time comparison. So even with the hashes there can go nothing wrong. The hash will look like this. You see there is a rounds parameter, and it is not only doing a single hash round like those simple hashes. In that case it's doing 160,000 rounds of hashes. So this is what it makes slow. Then here is the salt, and the rest of it is the password hash. And you immediately get this. This is all you get and all you need. You just store this into your database or into your profile. If you really want to know what it is, you can say identify, and it will tell you, okay, it was this algorithm. But you basically don't need it because it detects it automatically and uses the right algorithm. Okay, so the algorithms are much slower than the simple hash. You can tune them, so if in 5 years the computers are 100 times faster, you can just increase your rounds parameter to make all the stuff slower. It's configurable, so you can choose what kind of hash you want, you can choose the parameters to the hash, and you can even do hash upgrades comfortably. Aside from storing and verifying passwords, it also has some random functions in it, and it also has weaker older functions if you need some sort of compatibility. And in the documentation there is usually a red sign if the algorithm is too weak. So this is how you can configure it. For example, you can say I want to support this and that scheme for hashing the passwords. You can say that is the default, and you can say that this is something you want to get rid of. It's basically for migrations from weaker to stronger hashes. And if you say deprecate it and a user logs in, it will just upgrade the hash at the time when it has the clear text password. And it's done quite easily. You just say verify and update. If the password is wrong, it will just tell it is wrong here. And of course there will be no upgrade in that case. If you give the correct password, it will say okay, that was correct. And it will also give you the upgraded hash for the stronger new algorithm. And you just need this single check and save the new hash into your profile, and you are done with your upgrade. So a word about weak hashes. You could have the idea, okay, we are doing this on the fly. If a user logs in, the hash gets upgraded, and we keep the weak hash until the user logs in somehow. Or if you migrate from an old system to a new software, you could just import all the old hashes into the new system and just use this upgrade method. The problem is, if you have users that never log in, then you will keep those weak hashes forever basically, and you are somehow endangering this user. So think about whether you really want to do this or whether you want just to globally invalidate all the stuff. If you don't want to globally invalidate, you can also use double hashing. This is too small to read anyway. Maybe look it up in the slides. The idea is, instead of having a weak hash, you just wrap the strong hash around the weak hash, like you do for a clear text password. You wrap around the hash, so you do it with the strong one. Yeah, another point of the problem is what's an acceptable password. If it's too simple and so on, you will run into a problem, not because of your hash algorithm, but just because it's in the dictionary somehow. So maybe what you want to offer to your users is some sort of strength meter for your password, or even some advice. The problem is with strength measurement is that it's hard to do. Obviously, if you're just checking for the length or for a set size, the set of characters, or for some specific rules, you still can make two simple passwords. And I recently worked a bit on this, and there was the idea of maybe using the Shannon algorithm to determine how much information is in the password. The problem is this self-entropy measurement is more useful for longer text if you have lots of input, but if you only have 10 characters or so, it's a problem. And the idea, and what I maybe want to discuss later, is if one maybe could use a modified Shannon algorithm that somehow uses indicators. So if you use a lowercase a, it will somehow assume that the complete lowercase characters were candidates. Or if you use a German special character, it will assume that you could have used all those characters. If you do password strength measurement, never say to the user that it is good, because you can't know if it is good. Maybe just only tell if it is really bad, because that is rather safely to determine. And the best advice maybe is educate your users so that they choose real passwords. Okay, we have to skip a bit. Yeah, I'll upload a slide so you can read the rest online, sorry. It's a bit bad timing.
So, thank you first. Question time there.
Great talk, thank you very much. I was wondering, so what do I need now to hack the Waldmann wiki?
The bug is fixed, so that security issue won't work anymore. And we use parslip now.
When you described the timing attack for using the string comparisons, how would that actually work for if you're comparing hashes? Presumably, you wouldn't actually.
It's not that easy. That's the reason why I use clear text as an example. But you maybe can get small indications that just reduce the amount of stuff you have to try. But you're right, it's getting much more complicated.
Yeah. Always regarding of timing attack, what's your opinion about timing attack on web application through the internet? I mean, latency and so on give a ripple and random times to the response.
Yeah, of course, if you have a real-time system like some hardware and you can directly wire to it, you have no time fluctuations. If you are on the internet, time will fluctuate naturally. But don't assume that this will save you. If you are doing lots of requests and good statistics, the attacker might still get some clues out of it. There are papers on the internet and usually some talks at hacker conferences, and you are not safe due to this. That's in short.
More questions there.
Isn't the whole problem with passwords that the user gets to pick them? Why don't you just give the user the password and he has to remember it, and he's going to use a password store for that anyway, on the web at least?
Yeah, using random passwords somehow and storing them is a solution. The problem is maybe then your password store, is it really safe, or did you outsource it to some company that gets their own break-in or something? But using long random passwords is part of the solution. It's far better than using some normal words or something. But yeah, you have to manage the storage. And you also have to manage that every site, of course, should get its own password. But using a password manager, of course, is maybe part of the solution.
Anybody else? Someone behind the column I can see? No. So, thank you very much again. So the coffee break will start in minutes. See you later.